Swayam Prabha. Digital India. Educated India.
Nanotechnology is essentially the science of very small particles or materials. When materials become small in dimension, well, they have new properties. So gold will no more look like gold. It has a different property. Now, if you collect all those small particles together, you create a nanomaterial. This will have completely different properties than the corresponding bulk material. Let me show you that with an example. So this is a soluble form of gold. It is this violet, or what we call a wine red kind of a solution. But if I take this out now, you won't see this as gold. This contains particles. When I say this contains particles, you have to believe it. Remove this water, this is water, remove this water, this will be a black powder. But this black powder has very different properties than the bulk gold. So keep this aside. This is another such material. This is also composed of small particles, but it is composed of iron oxyhydroxide. Now this material, if I take this out, I am putting it on my hand here. So you see on my palm, you see particles. These particles have a very different property that it will remove or it will scavenge arsenic from water. So now what we do is we take this and create filters, water filters, using this. And that can be used for people. So here is an example of that. This one is such a water purification plant in the state of Punjab. So these things contain that material. So what's so great about it? This can remove arsenic. Well, a problem of some hundreds and hundreds of years. We know about arsenic for the past 110 years or so in nature. We didn't have the right kind of solution. This can remove arsenic at an affordable cost of less than 2.1 paisa per liter of water. So the government has adopted this. It says that, well, it can address the arsenic problem across the country or the world. So what is the basis of it? The basis is affordability and sustainability. This is possible only with nanomaterials and not with bulk materials. Because each particle, which is very tiny, has a capacity to remove lots of arsenic. If a bulk material is used, you will have to use probably about 40, 50 times that quantity. That leads to increasing cost. That leads to large purification plants. This very same plant, which is supplying water to 2,500 people in a small shed, as I showed you, this will become 10 times larger. So affordability becomes very different. So this is the essential power of nanotech in that segment. But this can happen in many other segments. For example, I told you this particular thing is a different gold. This can detect species, let us say contaminants in water. Same way it can detect a particular kind of proteins in urine. Or it can detect something else in another biofluid. This can detect diseases. So you can start thinking about different aspects of nanotechnology. I told you about one such material. The periodic table is full of elements. They have plenty of compounds. Lots of nanomaterials can be made to address different problems. I have been a scientist fascinated by the fundamental science of molecules, matter in general. And this is called materials chemistry, materials physics, materials science in general. For quite some time, I have been looking at the very fundamental aspects of such science. Some time ago, about 22 years ago, I decided to look at matter from another perspective. Can they be of use to society? At that point in time, in India, we had this issue of water being contaminated with pesticides. So there was this concern, what can you do? And I thought, the kind of science that I do, how can that be used to tackle this issue of pesticides in water? We found in 2002 that nanoparticles can break pesticides. That was my very first patent. And today there are over 120 patents. But then that was the very first thing. Then I thought, well, what is the point in having a paper and a patent and putting that in the cupboard? Why not we take it to people? I decided that we would have a pilot study of whether this can really remove pesticides in the field conditions. That resulted in piloting of this technology in the field. Well, what is the point in having piloting unless this reaches people? So I went to companies and I gave my technology. So we started a technology transfer. Institute got some royalty, and in that process we reached about 10 million people with this technology of providing clean water to people. And Institute got some 2.5 crores of royalty in that, and that's how this whole activity started. So you ask me, how did it all start? Yes, this is how it started. But then we decided that we should expand. Water is not just pesticides. Water has many other things. We should address all of them. Material science is vast. Can you address all of these with different materials? Can they be of use to our society? Can they be affordable? Can they be environmentally friendly? That took us to this larger mission. And that was this, that Padma Shri came as a result of that. Several other things also came as a result of that. Everything got funded by our government and our great initiatives and our institution, our people, students. So that's the long story. If at all, science has to go to people, That's ultimately what I just now said. You have to start with a vision. That vision, that what you do tomorrow should serve certain purpose. I have to place that right in the beginning. The fundamental reason why we sort of became successful in this is by placing that objective right in the beginning. Why am I choosing this research problem? Why am I using that particular material? Why am I choosing this kind of method of synthesis? So if I don't have all that, I may create a fantastic technology, but it will not reach people. So we decided that anything that we work on should be affordable and sustainable. So the periodic table is very big, but I can't work with all of them. I can only work with a few elements which are affordable and sustainable. I say that they have to be affordable, meaning the synthetic methodologies, piloting and all that should be affordable. So I need to place this objective right in the beginning. If you do that, well, your broader canvas might get narrowed down, but then in that narrow space, there are plenty of things. So you think about it, biology is nothing but carbon, hydrogen, nitrogen, phosphorus, sulfur, a few elements, just a few elements. That's what biology is. You and I and him, they're all made of just these elements. But you see, how many people? We have 8 billion people. So this diversity is built with just a few elements. Similarly, there is a lot of diversity that is possible, although you are restricted with a few elements which are affordable and sustainable. So I would say that placing that larger objective and addressing this problem with the focus to address that specific challenges will get you. That's the fundamental insight. I must realize that I'm not working in UC Berkeley. I'm not working in any of those places, although they're all very dear to me. I worked at those places, but I am in India. And if I have to address India's challenges, I have to address them with completely different kind of framework. And that's why I chose this affordability and sustainability. Now, in the areas you might be, those of you who are watching from biology background or artificial intelligence or any other subject area, you must keep this in mind that you are limited by your cities, countries, regions, limitations. In the clean water space, what is a fundamental limitation in India? Any technology will reach field only when it is cheap. Cost is a fundamental thing in India. Smartphones did not reach people when the costs were something, right? Even today, smartphones are available at 10,000 rupees and many people can buy it. 5,000 rupees, even more people can buy it. Cost is a very important thing. So water has to be affordable. Healthcare has to be affordable. Anything has to be affordable. So you have to put cost in. So therefore, when I use a material for my synthesis or any such process, I ask the question, what does it cost for a kilogram or a ton? The other point is that we must think about scale. See, we are talking about a country which is 130 crore people or more. What kind of quantities are needed for our country? If each person needs 10 grams of something that you are making, your technology is making, that is 10 10 grams into these 135 crores. We need to think about that. And can our country afford it? Our nature, can it afford it? Will the planet be safe with that? So there are 100 questions around it. Only then our technology can address country's problems. If with nanotechnology you address a challenge, you can address it with lesser quantity of materials, more affordably, and it can be more sustainably also. There are many dimensions to this. This can reduce the power consumption, this can reduce environmental costs, etc., which I am not getting into. There are different directions. As of today, nanotech is there in everything that we use, in soaps, in detergents, in hair dyes, in clothing, in all that we use a lot of nanotech, which probably you may not know, but they are all there. But there are many other areas where nanotech can make better impact. For example, we are a country which is largely agriculture based, right? Agriculture contributes in a big way to our gross domestic product. But we lose a lot of our produce. Can we protect them? Can we increase the shelf life? We are a country with so much of diversity, so many different food varieties we have. Can we make everybody taste quality sambar the way you get in Tamil Nadu? Can we get people to taste the same in, let us say, Jammu and Kashmir? So this is a food processing. This is a protection. Nanotech can go there. So there are hundreds of areas where nanotech can do better, which it has not done yet. A lot more developments are possible. Food, we are surrounded by the oceans. So much of variety, seafood. Can we do something about it? We have a lot of area where probably algae and all that can grow. Can we do something better with this? Can we use that bioresources to produce better biocompatible products? So if you start thinking about it, we have only started scratching the surface of nanotechnology. So this is where more challenges, more people must come in, address those challenges. An entrepreneur should be a different person. Look at the world with an eye to solve a current problem. Is there a pain point that people are facing? Can your idea address that pain point affordably, sustainably? Is there money in it? Is there value in it? Can you make an impact? If every problem is looked at from that perspective, you become an entrepreneur. The first thing an entrepreneur should have is a product. Can your idea be converted to a product? Any product. Can you conceptualize it? Can you give a physical meaning to it? Once you do that, you are on the right path. The country is ready to take such individuals and propel them to deliver.